This is question 11, have a go. So for part A, before we can differentiate, we need to get this in a fit state to differentiate. So rather than having root x, we need to think of this as x to the half. We can then differentiate it. The 2x becomes 2, and our second term, remember how we differentiate, we bring the power to the front, half of 8 is 4, and then we reduce the power by 1 to minus a half. Now for part B, we've got to find the equation of the tangent to C. So to be able to do this, we need to know two things. We need to know the point, and we need to know the gradient of the tangent at this point. So starting off with the gradient, remember how we can work out a gradient at any point. We just substitute the x value into the differential. So we're told the x coordinate is a quarter, so substituting a quarter into this, we get this. Now remember, x to the minus a half is 1 over the square root of x. So 4x to the minus half is 4 over the square root of a quarter. So popping that into there, square root of a quarter is a half, so a 2 minus 4 over half, which is 2 minus 8, which is minus 6. So the gradient is minus 6. Now, how do we work out the y coordinate on the curve when x is a quarter? We substitute the x being a quarter into the curve itself. So substituting a quarter into this, follow this through, we get a y value of 3 over 2. So we now know the point, which is a quarter 3 over 2. We know the gradient is minus 6, so to work out the equation of the tangent, we substitute it into this key formula here, and we get this. Rearranging this, we get this by just using the claw and multiplying out. We've been asked to put it in the format of y equals ax plus b, so that's how we must give our final answer. Now for part C, we're told the tangent to C at the point Q is parallel to this equation. So it's parallel to this, so we really need to be able to get the gradient out of this. So rearrange this to be in the format y equals mx plus c. That's what we've done over here, y equals this. So we know the tangent must have a gradient equal to 2/3 because it is parallel to this. Now when is the gradient 2/3? Remember, this differential works out the gradient, so we need this to be equal to 2/3. What is the x value which makes this become 2/3? So 2/3 equals 2 minus 4x to the minus half. Rearrange that and we follow it through, we get x being 9, so that's the x coordinates. We then substitute into the equation of the curve to work out the y coordinates, so substitute 9 into this, which we've done down here. We get the y valuing being minus 1, so the coordinates of Q are 9 minus 1.